Okay, so for number 4, we have to simplify this trig expression up here. So the way we're going to do that is using our trig identities. Alright, so let's rewrite this first. So we have sine to the 4th x minus sine squared of x all over secant of x. Alright, I want to try to simplify this down as much as possible until we don't have any trig identities we can use anymore. So the first thing I see is that this sine to the 4th is here, and there's a sine squared here, so both of these terms in the numerator have a factor of sine squared in them, so let's factor a sine squared out. Alright. And if we factor a sine squared out as sine to the 4th, well, that takes out two of the terms, and we're still left with sine squared of x. Alright, when we factor a sine squared out of a sine squared, we're just left with 1. So our numerator looks like that now, and our denominator we're still just going to keep as secant of x. Alright, so now in this numerator we have sine squared and this sine squared x minus 1. Alright, whenever you see a trig function squared and a 1, let's look at the Pythagorean identity that has to do with this square. So we know the fundamental identity, sine squared x plus cosine squared x equals 1. If I want this to look like this, I'm going to subtract the 1 over to get sine squared x minus 1. And on the other side of the equal sign, I'm going to have to subtract the cosine squared over to get negative cosine squared of x. So now I know in this numerator up here, I can replace sine squared of x minus 1 with negative cosine squared. That's a squared, and negative cosine squared of x all over secant of x. Alright, so now the next thing we're going to do is a little trick, is instead of thinking this as sine squared times negative cosine squared over secant squared, we're going to rewrite it as sine squared again. Alright, I'm just going to put this negative out in front. We have a cosine squared. Alright, and now instead of thinking of this as division by secant squared, we're going to think of it as multiplication times 1 over secant of x. Alright, so now I have this numerator times 1 over this, so these two pieces are exactly equal because this whole piece would go in the numerator and this piece would go in the denominator. Right. And now we have our reciprocal identity to say 1 over secant is the same thing as cosine. Alright, so now we have the sine squared and this cosine squared, the front, still with this minus, and now we're going to rewrite secant as cosine of x. And the last thing we can do is combine these two cosines, so we get negative sine squared of x times cosine cubed of x. And this is as simple as we're going to get because we don't have any identities where we're multiplying sine times cosine. If there's addition in here, we might be able to do something with the fundamental identity, but right now we just have to leave it as negative sine squared of x times cosine cubed of x. Alright, so that's what you have to do for number 4, factor out the sine squared, use the fundamental identity, and then rewrite division as secant as multiplication times 1 over secant. So now on to number 5, we want to simplify this trig expression. So we have cosecant squared of x minus cotangent squared of x. Alright, and this one would be really hard to simplify if you don't know the Pythagorean identities, but right away we can use Pythagorean identity that says if we take 1, we add cotangent squared to it, alright, we have to get out cosecant squared of x. Alright, so this is a Pythagorean identity. It comes directly from the fundamental identity when we divide both sides by sine squared. Alright, so we have this, and we want to make this identity here look like what we have at the top. Well, the way we do that, we have a positive cosecant squared, and here we have a positive cosecant squared. So we're going to subtract this cotangent to the other side. You get 1 equals cosecant squared of x minus cotangent squared of x. Alright. But now this piece here is exactly what we have written up there, so we can just use the other side of the equal sign, so this equals 1. Alright, so this whole thing, expression here, simplifies just down to 1, similar to how we have the fundamental identity where sine squared plus cosine squared equals 1. So this answer here, we could just leave it as 1, and that'd be your final answer. Alright, so now the last problem on this page, number 6, we have to find the inverse of this function here, which has a trig function on the inside of it, and it says we're only using these x values, you want to find the inverse of this. So the first thing, when we find an inverse, we have to make sure it's 1 to 1. And if we're looking at sine of x without all this extra stuff on the inside, then we made this 1 to 1 by making sure that x was between negative pi over 2 and pi over 2. Alright, so whatever's on the inside of our sine function has to be in this range. Alright, so for our specific example, we have pi x minus pi on the inside. So just like here, we have to make sure pi x minus pi is between pi over 2 and then bounded from below by negative pi over 2. Alright, we're just going to solve for x to make sure the x values that we're using here are the same as the x values that we're using up here. So the first thing we're going to do is add pi to all three. So negative pi over 2 plus pi is positive pi over 2. Alright, here adding pi just gives us pi x. Here pi over 2 plus pi is 3 pi over 2. And now the last thing, we're trying to solve for x, so we're going to divide both sides by pi. Well, that just cancels out with the pi here and we get 1/2. Same thing happens over here, the pi gets canceled out and we get 3 halves. So if we want sine of pi x minus pi to be 1 to 1, we squeeze it in this range between 1/2 and 3 halves, which is exactly what we're doing up here. Alright, so we know now that this function f of x is going to be 1 to 1, so now we can find its inverse. So the first thing we're going to do is call this y equals 2 minus sine of pi x minus pi. Alright, and now the next thing we're going to do, we're trying to find the inverse, so we're going to switch the x's and y's. So this y here is going to be x equals 2 minus sine. Now this x inside the parentheses is going to be a y now. We have minus pi. Alright, so now our goal to find the inverse is we're just going to solve this for y. So the first thing we're going to do in these type of problems is isolate this trig function here. So to isolate this, we're going to subtract the 2 over and get x minus 2 equals negative sine pi y minus pi. And again, trying to isolate this, so we still don't want this negative out in front, so we'll multiply both sides by negative 1. This right side, the negative, will be negative x plus 2. And now we have the trig function by itself, it's sine of pi y minus pi. Right. And now here's the problem, because we're trying to solve for this y, but it's inside of this trig expression here, so we can't just add a pi to the other side because it's inside of another function. So again, we're going to use inverses, because we know if we're talking about regular sine, we'll plug in this value and get out this value. Well, if we go to the inverse, we switch those two, so the inputs and outputs switch. So here we're inputting this and getting this as an output. Well, with sine inverse, we switch those around, we input this, and we'll get this out as the output. Alright, so we just switch these two using the inverse. Now that's good because y is out here on the other side of the equal sign, so we can solve for y. So to solve for y here, we're going to add pi. So now we have sine inverse of negative x plus 2 plus pi. Alright, and that just equals, pi y. Alright, and the last thing, again, we're trying to solve for y, so we're just going to divide everything by pi. So I'll just write it like this, sine inverse of negative x plus 2 plus pi all over, we just divided by pi, and that equals y. And the last thing we're going to do is just going to rewrite, instead of calling this y, now that we solve for it, we're just going to take it back, and we're going to say this is f inverse of x. Alright. So when you're trying to find these inverses of trig functions, first make sure it's 1 to 1 by doing some type of inequalities like this. Sine gets split in between negative pi over 2 and pi over 2. Cosine would be 0 to pi. Alright, so whatever's on the inside of sine or cosine has to be in those specific ranges to make it 1 to 1. Alright, and then you're going to isolate this trig function that took us down to this point here. Use the inverses to switch the inputs and outputs, and that'll bring the y outside of the trig function where you can solve for it and gets our final answer down here at the bottom. So that's how you find the inverse of a function that has a trig value on the inside of it.